Hello and welcome to Food Safety Fridays. My name is Simon Timperley from the International Food Safety and Quality Network. Today's guest presenter is Brett Greenlee from Trace Analytics, our good friends. And today's topic is compressed air quality testing, what you need to know. So good morning, Brett. How are you doing? Nice to have you with us.
Good morning. How are you?
I'm good, thanks. And we always ask every presenter where you're joining from today.
I'm joining from the United States, from Pennsylvania, Pittsburgh, Pennsylvania.
And what's the weather like in Pittsburgh at the moment?
A little bit of snow, a little bit cold, but you know.
Getting ready for the for Christmas, some nice snow. So tell us where you're joining from in the sidebar. We've got Sharon from Arizona. I'm sure it's probably not snowing there, but I might be wrong. Timothy from Ontario. Mark from Lancaster, PA.
Oh, local, yeah.
Lancaster. Local to you. maybe know them. Gladstone from Ghana. Marine from Pakistan. Stephen from Kenya. Patrick from Senegal. Arisa from Ireland. Look at that. Literally all over the world, and you are all very welcome. I'm going to play the sponsors ads now, the kind sponsors of Food Safety Fridays, then we'll be back for Brett's presentation in a couple of minutes. Okay, I'll be back for the Q&A later. For now, I'll hand you over to Brett.
All right, well, thanks for the introduction, Simon, and I'm really excited to be here with everybody today to talk about the fourth utility, the commonly overlooked fourth utility, compressed air, and the quality and purity of it, and that impact that it can have on your product, your consumers, and potentially even your facility. So we'll get right into it. We're going to talk about what you need to know and how you can set up a monitoring plan. But first, just got a little objective slide here, talk about those risks and those risks that come in your compressed air quality, the regulations and some of the standards that surround them, potentially some mitigation efforts, and then finally verification, those testing methods, those monitoring plans, maybe some case studies, etc. So again, compressed air testing. What is compressed air testing? So with our compressed air, we know that there are contaminants in the air around us all the time, whether it be particles, water, oil, even microorganisms. And these photos I show at every single presentation. These are some great photos that we have found. Now, these are extreme examples of those contamination. We at Trace Analytics are looking for these contaminants in trace amounts, pun intended. But you can see kind of left to right there. What you're looking at here is water. There's also some microfilm in that water. So again, speaking to those contaminants, we're looking for particles, both viable and non-viable. We're looking for particles such as rust and microorganisms and other things. We're also looking for oil and oil carryover, as well as water. Now, where can these contaminants come from? Let's start with particles. Obviously, any of these contaminants can come from being in the ambient air in large volumes, and then they're going to be compressed through our compressor system, right? So we're going to see them in a much, much higher concentrations once they're put through that compression. Now, the important part to know here is where these can come from. And most of the time it's ambient. Other times it can be from the compressor itself. Sometimes it can be from our system or from leaks, again, ambient and things like that. But more often than not, the most pointed part of this is what is compressed air testing and how do we validate and verify that our compressed air is free of that contamination, free of those particles, water, oil, microorganisms, potentially gaseous hazards, etc. So let's dive into some of the meat and potatoes of this presentation. Really, it's about, let's look at this system-wide. Let's think about the contaminants that exist in the air, everything we just talked about. And then let's identify where our risks are at and how to categorize those risks. Now, identifying the hazards, we talked about the particles, water, oil, microorganisms, potentially gas purity. If you're using a pure gas system such as nitrogen or something like that, the nitrogen purity is of great concern. So we can also, we're also looking for contaminants such as gaseous contamination that shouldn't be in your pure gas. But what we need to do kind of before anything is establish our critical points. So when you're looking at your compressed air system, that fourth utility, the commonly overlooked one in all facilities, as being a source of contamination, we're looking to establish those critical control points, and that is every point of use. Now, how to identify the risk for each of those points of use is to categorize them kind of on the right-hand side. You see, we get some direction from the BRC and the BCAS on direct contact, indirect contact, non-food contact. Once you kind of can get a view of your entire facility, and you can start to break down which of these points of use, which of these critical points have the highest risk, right? Direct contact, indirect contact, or non-food. Then we can start to take and establish preventative measures for each of those points of risk, or potentially the entire system. Now, this is one area that I really wanted to focus on, leaning on our service providers. If you're not doing testing now, we have a great distribution network that allows you to lean on them for more guidance. They can take these tests, they can do this testing for you often, but most importantly, these preventative measures, and then later on in this slide, we're going to talk about them again. But what those preventative measures look like to prevent contamination to your product, to your consumer, to your system are purifications such as filters, dryers, maybe the equipment itself, depending on your situation, your level of risk, and the contaminations that are could be in your facility or that you've identified to cause harm to your product or consumers. Monitoring and those preventative measures, obviously, once your validation is completed, we're going to continue to verify that this is working, right? Our established preventative measures are installed and they're working the way that they should be. So we're going to monitor for that compressed air on a regular basis. And that can look like a couple different things that we're going to get into here in a little bit. But it all leads back to the big old ISO 8573. If you're looking for direction and compressed air quality, ISO 8573 is always where you want to look. That's where we're going to get into here in a moment. But after your monitoring plan has been established and what those preventative measures have been put in place, we want to also establish corrective actions. So anytime you would have a failed test for your purity limits of your where your risk points or your critical points were, you want to have a corrective action plan. And that is another thing I wanted to talk about: service providers. Those service providers are, they're the experts in those preventative measures and those corrective actions. We are a third-party accredited laboratory that's going to take those samples and tell you how clean, dry, and oil-free your air is, or free of microorganisms. But really, on the tail end of that report, if it is a fail, then you can partner with someone who will help you with your corrective action plan and how to improve upon those preventative measures, that purification, those dryers, that equipment itself, all for your application. Now, obviously, most importantly, I'm sure if you're in quality, you know, documentation is probably the most important part of this entire process. Document, 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 all of the above. Again, what this presentation was really supposed to be about is something that Trace really has wanted to get in front of our audience for a long time, and that is how to create a monitoring plan. And the very first part of that is always identifying the risk and categorizing it and seeing where the hazards can be. Now, we talked a little bit about ISO 8573 testing. That is the ISO 8573 standard is where all things compressed air quality lives. So we'll talk about some of these risk-based standards and some of the methods that surround them. ISO 8573, now there's a chart there on the left-hand side, and I encourage you to explore this chart at a later time, not on this presentation. I'm really not a fan of having charts on presentations because they're very difficult to navigate. But ISO 8573 is going to give you what levels of purity classes, what levels of contamination meet what levels of purity classes. Now, most folks come right out of the gate and they say, we want a 111 particle water and oil. That is very difficult to achieve in some cases. Now, although that may be applicable to your product, sometimes it isn't. Again, it goes back to that identifying the hazards and just establishing what purity level you should be testing to for your facility. Now, some of these food safety standards on the other side of this slide are those like SQF, which I'm sure many of you are familiar with, the Food Safety Act, if you're in the United States, and then the FDA. Now, I wanted to draw attention to their language a little bit and what they actually require, because most of them are rather vague. With the exception of the BRC that gives you a little more guidance and a little more direction, the SQF requires a hazard analysis, minimum yearly testing for compressed air, and the Food Safety Act also requires a hazard analysis along with regular monitoring, and the FDA just says purification required and do not introduce contamination. Although all three of these kind of call out, testing your compressed air, none of them really give you too much guidance, which is why we're here today, to give you a little bit of guidance along your compressed air quality testing journey. The last thing I wanted to talk about while we're on this slide is within this ISO 8573-1 standard, it goes all the way through -7. It's a pretty lengthy standard, and we would be here for a long time if we were going to discuss over all of it. This ISO 8573 chart, the one thing it does not include that we get a lot of questions about is microorganisms. That can be found in ISO 8573-7. Now, although there isn't a chart yet, it is on the way for different levels of microorganism contamination or viable particle contamination, and what purity classes are going to be identified. So soon to come, not here yet. Obviously that is largely risk driven by the end user. What are our alert levels going to look like? How are we going to test? It does call out how are we going to test, which we'll talk about in a second, but I did just want to bring that up. If you're looking for microorganism assistance, ISO 8573-7 is where you want to go. That'll be your home for microorganisms. Now, a little bit of guidance on how to test and what it may look like to test. So we've talked about the risks and the contamination. We're looking ultimately in layman's terms for clean, dry, oil-free air and potentially free of microorganisms. We've talked about how to take our critical control points and break them down by risk and categorize them by direct contact or indirect contact. But now we're going to talk a little bit about what it may look like to actually monitor for them. What are the methods that we can use? Now, All of these methods on this slide, you'll see down at the bottom, it says if there's a check mark, they are ISO 8573 accepted. So not all of these testing methods are provided by Trace Analytics. Some of them are provided by other vendors, some of our competitors, and things like that. But for full transparency, I wanted everyone to be able to know and understand what is out there to test my compressed air monitoring and what is ISO 8573 accepted. So some of the pros and cons, there's two types of testing, right? There's laboratory testing and there's continuous monitoring. A lot of the folks that we see with continuous monitoring have a high enough risk that they're actually doing both continuous monitoring and laboratory testing. Now, the pros kind of with laboratory testing are third-party accredited results, which is a great tool in the toolbox, especially if you were to ever get audited. Oil vapor identification. So we can actually at Trace with laboratory testing, we can take those oil vapors that we may find as contamination in your system, and we can actually identify those hydrocarbons to help you point out maybe where they are. We can do oil aerosol, which is oil particulate rather than oil vapor. And then microbial results. And we can also help identify those microorganisms. Now, with continuous monitoring, what you're going to see is you'll get real-time results, which for those of you that have that level of risk, you may want to see at all times what your performance is doing, maybe as simple as dew point. But you also get, again, since you're getting live results, you'll get early indication that maybe something is wrong. Maybe that's the time to do a manual sample and get it to the lab for some more specific identification and purity limits. And then you'll also get, again, with the dew point monitoring, you do get high accuracy with that live monitoring. Now, again, for these contaminants, we talked about what they are. I know I keep saying them. You'll notice when I present, I can be really redundant. And that's always because I'm trying to get that retention. But the particles, the way we can monitor for particles is through microscopy, which is, for those of you that don't know, looking through a microscope and counting particles. You can also use a laser particle counter, also accepted by ISO 8573, or gravimetry, which is swaying those filters in and out. For water, we can use dew point hygrometers. That would be part of kind of that continuous monitoring, but they do have handheld ones that will allow you to check your dew point live and in your hand, and then move on to the next one. Or colorimetric tubes, which is what we use at Trace Analytics, which will give you a moisture reading, and then in our lab through our method, we can give you a dew point result. For oil vapor, you can use a gas chromatograph, gravimetry, or a photoionization sensor. Now, I could barely say the word photoionization, so I don't know too much about it, but it's not an ISO 8573 accepted method. So my knowledge of those sensors is very limited. We use both gas chromatograph and gravimetry at Trace Analytics. For oil aerosol contamination, again, gas chromatograph or gravimetry. For pure gas testing, gas chromatograph, oxygen sensors. And then last but not least, for microbes, the only accepted method by ISO 8573 is through an impact sampler plus TSA plates. I know that was a lot of words, so I'm going to stay on this slide for a minute in the event that you want to screenshot it or take down a couple more notes. But this is really where the meat and potatoes kind of are for what your monitoring plan is going to look like in terms of how we are going to test, how we are going to know whether or not our air is as pure as we need it to be. Digging into those monitoring plans a little bit more. Obviously, in anything we do in quality, we're going to validate and verify. So any installation or anything like that after the initial validation, and we've identified what our purity class is going to be, we've already installed or our preventative measures. Now we're going to validate our system and see how clean, dry, and oil-free or microorganism-free our air is. And again, I know I said it, but we're going to identify every single point of use as a critical point. And we're going to take those critical points as presenting a risk to us, and we're going to categorize them by direct contact, indirect contact, and no food contact. And then we're going to monitor those points and at what frequency. At what frequency should we put into our monitoring plan to validate and verify our system? Now, this is oftentimes where most people get a little bit nervous. I've got a big facility. I've got lots and lots of points, and the feasibility of me doing all of these is very it's going to be very difficult. That's okay, because most of what SQF says and most of what the Food Safety Act says, most of what these standards say is regular testing. Now, the BCAS does recommend at least twice per year, but it doesn't say you have to do every single point. So what we usually suggest is that in those monitoring plans, you're doing a percentage of all of your points of use. Now, you could have different purity limits for different areas of the facility. Some of them may not all be as much of a risk to you, but in those monitoring plans, once you've identified the risk and once you've identified the purity limits that you're going to test to, we can do a percentage of all those point of uses. So if you got 100 points of use in your facility and you're in a large facility, 100 points is a lot, but just for even numbers, we can do maybe 25% of that on the first quarter and 25% in the second quarter, 25% in the third quarter, and 25% in the fourth, and so on. We at Trace Analytics always recommend quarterly testing. Most of our customers are doing quarterly testing, and that is really so that we can capture climate change. For those of you that experience a 4-season type year, these compressed air systems are dynamic, and we always want to make sure in quality that our food or our product is as safe as it's going to be. And with the dynamic of this fourth utility being compressed air, that contamination can fluctuate throughout the year. So that's why we always try and do quarterly testing and then do a percentage of all points of use. That way, it's not so much we're not putting so much on our plate at a time that we can chew. I just want to speak to the power testing a little bit, because we did talk about some of the pros and cons of laboratory testing and some of the pros and cons of continuous monitoring. Now, we had a manufacturer at some point that was having trouble with hydrocarbon contamination. They were testing with a laboratory and they were getting high levels of hydrocarbons. Being able to identify those hydrocarbons, they were actually able to trace back all the way to a vessel in their compressed air system that they opened up and realized that someone had painted a glove to the inside of that vessel, and that glove was off-gassing hydrocarbons. They removed the glove, repainted, and their air quality test came back with a pass. Another manufacturer we were having was actually performing their regular air quality testing when they realized that their dew point reading was really, really high. They hadn't noticed it because, they came in, they don't know how long it was like that, but the moment they started testing, they realized their dew point was going to fail with a colorimetric tube, and they were able to fix their dryer and at least prevent their next couple batches from being destroyed. Another microorganism win that we've had in the past that I thought was in this slide, but it is not, was we are getting alert levels of microorganisms in a compressed air system for a customer at one point, and we were able to help them troubleshoot and identify that pigeon feces were the cause of the contamination at the intake side of the compressor system, which they were able to mitigate that issue moving forward, and were able to get passing results and protect their product and their consumers. All of this can be, again, back to those preventative measures, that intake filtration, downstream filtration, point of use filtration, dryers, things like that. But these things can go wrong, especially if there aren't redundancies in place, which is why continuous monitoring, continuous regular monitoring is always important. And having this monitoring plan in place so that we can identify those risks, identify those hazards, have a plan for how to monitor them, and then what to do and to document when something goes wrong is of high importance. Now, we don't want you to be intimidated by any of this process. Again, you can see I put that ISO 8573 chart back in there today. I encourage you to dive into that at some other point. But just know that you don't have to go in at this alone. Trace Analytics is always here to help navigate through ISO 8573 and navigate through this chart. We also provide risk assessment templates. Now, they're pretty vague, I'm not going to lie, but it does kind of sometimes give you a direction on how to break down your points and then how to categorize them and divvy up which ones are going to be tested and when. Information on monitoring plans that can be found through our website. Another thing that we offer if you're new to compressed air testing is what we call a diagnostic test, or even a baseline test we can provide. Those two types of tests allow you to take a glimpse at what your compressed air system is doing now. If you're new to testing and you're new to the ISO 8573 chart, again, a lot of folks come to us and they're like, hey, I don't know what to test to, so let's just go with a 111. That is a very, very strict purity class. And at the end of the day, sometimes these systems aren't capable of performing that well as they currently sit. So this diagnostic test is a great way to grab a glimpse of your, what your compressed air system is doing now and tell you what it's performing to now, and what purity classes you are reaching for particles, water, and oil, and those types of contamination. And then we can partner with your service provider to make improvements upon it, to put some of those preventative measures in place, to act upon some of those alert levels and actually maybe identify what they're going to be. Some other resources that I wanted to discuss with you that are available, again, just to reach out to us or give us a shout. I'm sure you may probably get this presentation afterward and get the slides too, so you can probably look through this yourself. But some of these materials on the right-hand side, this is a chart that we've put together that is based on what we have seen, results we have provided to customers. So based on what results we've provided to customers, we've asked some questions along what types of systems they have and what we've noticed to have shed particles versus not shed particles, what we've noticed to help with dew point readings and not help with dew point readings. So that's a great little chart to understand what material your system is now to the worst material. Now, that's not to say that if your system is made of galvanized piping, which is really low on this list for metals, that you can achieve high purity classes, but you need to partner with a service provider to put preventative measures in place to make sure that they are. We've had a customer recently go through a challenge where they had moisture problems in their system. So then we partnered with a service provider and they had a dryer installed. Then when we dried the air, the particles that were being trapped in the moisture were now able to flow freely through the system. It was a galvanized piping system, and that system is very difficult style system to mitigate particles with. They were able to install end-of-line filtration, and we were actually able to get them to a class 1 particles purity class for ISO 8573, which is a very impressive feat for that type of system. So it can be done. Now, those filters will probably have to be changed very regularly, which again re-solidifies the fact that we need to be testing regularly to make sure that our product isn't contaminated, that we're not going to affect our consumers. And the last point I wanted to talk about too, and I said it earlier, was like the system itself. The system itself is subject to corrosion when your moisture levels are high. It's not supposed to have high levels of oils and high levels of particles in it. So for your system itself and the sustainability of your facility, I know this might not be the audience to have that discussion, but it's something to think about when you're talking about sustainability and how long we can produce and things like that. We're looking to get a sustainable product when we install one of these compressed air systems. It's not an inexpensive investment, right? So for the longevity and sustainability of the equipment itself, to be able to check for that and be able to mitigate that part of the aspect too is really, really important. On the left-hand side here is really where I really find this beneficial to most of the people who approach us for the very first time that have never done compressed air quality testing and aren't really sure where to start. So that chart that I've showed you, that ISO 8573 chart, what we've done is we've taken that chart and kind of broken it out. And as you can see there, this chart is expressive of the opinions of Trace Analytics, but we kind of take that chart and break it down into layman's terms. These purity classes mean this level of purity. These purity classes mean this level of purity, and these level, and so on. Now, the BCAS guidelines, they used to be different for direct contact versus indirect contact. But now the BCAS has made them the same purity class, but it gives you a direction to go. Again, so for direct contact and indirect contact, the BCAS recommends you're testing to a 1-2-1. But what I wanted to draw attention to is at the bottom of that PDF file there, you can see this is data that Trace Analytics has collected, again, on reported results that we have provided to these industries. Now, we have a more extensive list than just this. It's not as, we have, what's on there, 8. I think we have one that goes maybe to 15 or 20 different industries. But it also, that allows you to see if you're in any of these industries, hey, or an adjacent industry, where do I start? If I've never tested before, what purity classes should I be testing to? We can't tell you that. You've got to kind of get with your quality program and your team and identify what your purity classes are going to be. But we can provide you information based on what we've seen people in your industry do. So we do have some of that information. And again, we offer baseline and diagnostic testing. So that allows you to test your system and get a glimpse of what it is doing right now. And then maybe you can make improvements upon it to get to some of these purity classes that these other folks are testing to. These tools are available at all times. All you have to do is reach out to us or go to our website and you'll grab those out. Again, I know this seems real trace heavy. We are a sponsor, but what we really want is to educate on compressed air quality testing. What we really want is to get all of our food manufacturers testing their compressed air to some level of standard, whether it be with us or anybody else. But we do want to be able to be a resource for you to lean on as you get into this process and as you continue to work through it and establish your monitoring plan. And even once that monitoring plan is established, we want to be able to help you continue on for many years to come. Just to give you a little shameless plug for Trace Analytics, we've been compressed air testing for over 30 years. I think we're at 35 now. That seems to go by quicker than I anticipated, but we are a third-party accredited laboratory. So those laboratory results that I talked about earlier, that's what we do. We test the ISO 8573, everything we discussed in this presentation, but we also do some clean room specifications and much, much more. We have very high-tech equipment, which allows us to run hundreds of samples per day and the ability to work with clients all the way around the world. Not just do we do food safety, but you can see there, I was introduced to this industry through breathing air testing. So the purity of the breathing air for scuba divers and firefighters is how I was introduced to this industry. So again, we're largely education focused. We want to help you test your compressed air for those contaminants, help you with those monitoring plans, and assure that everything that you're doing in those purity classes you've established have been met. Any questions now, Simon?
Sorry. Yeah, thanks. Thanks very much, Brett. Let's just do this. Just bear with me. It is a question about these slides. It's been recorded, this, and afterwards we send a follow-up email with the webinar recording, the slides, and the certificate. So don't worry, you can look over them again at your leisure. Okay, so in terms of questions, got one from Valentina. Please feel free to type in any question that you may have so that we can pick them up with Brett while he's here. Valentina, do third-party laboratories typically work directly with food production facilities to test and monitor compressed air quality, or do they primarily collaborate with consultants who develop and implement HACCP plans?
The answer is yes, we do both. So oftentimes we work with customers directly. Some of our customers have very robust plant maintenance teams and things like that can actually perform this testing. They work together very well. However, we also work with a lot of facilities that are using consultants or service providers. But largely, if you ask me my personal opinion, I would always rather see someone working with a consultant or a service provider who can help them when this testing comes back. Now, these consultants can also give you more guidance. As a third-party accredited laboratory, like I said, we can't tell you what to test to. We can't tell you what your purity class limits should be. We can tell you what we've seen. We can tell you the data that we have in your industry a lot of times, but typically for folks that are using a consultant, they get a little more guidance or on what they should be testing to, what the risks can be, and they can even help them with the testing process and the monitoring plan too. It's just it's a little bit easier oftentimes for someone to work with a consultant or even their compressed air service provider to help them with a little more guidance, a little more technician level. You get a report back from us and it's a fail. You call us and we'll help you as much as we can. But at the end of the day, those service providers are going to be the ones who have to make a recommendation on what filtration to install, what type of dryer to install, so it's easier sometimes to start there in the beginning. There's a lot of value in working with a service provider that knows your system.
Yeah, makes sense. Question from Timothy. How did we arrive at the targets for various applications? Are they universal or based on localized risk assessment?
So I can't speak to the BCAS. I think he's talking about purity class limits. I think for BCAS they recommend a 1-2-1. I don't know how they came to that, but they used to actually have it. It was different. Direct contact was 1-2-1, and indirect contact I think was 2-4-2 or something like that. But now they've changed it so that both direct contact and indirect contact are 1-2-1. So speaking to the BCAS, I don't know how they came to those limits. For me, again, like it says, how do we arrive at the various applications? That's all really risk focused for your facility. So again, I just said it for the last question. Us as a laboratory, we can't necessarily tell you what purity classes to test to, and that is actually our largest hurdle. I wish we could. I wish we could take the data we have and say, hey, there's what you need to be testing to. But unfortunately, we're bound by that conflict of interest. And, that's why, again, working with a consultant or somebody who can help you determine those limits. If you don't have an idea where to look, you can always lean on us. We can give you the data that we have, and you can work with your quality team to determine what those purity limits should be for your facility.
Okay, thanks, Brett. Question from Sonia. You also test for nitrogen?
We do. So we can test for nitrogen purity, and we can. We're getting a large influx of nitrogen because of cost. At least here in the United States, the cost for third-party nitrogen is getting really high. So a lot of folks are getting nitrogen generators installed, or they just want to validate or verify that the nitrogen they're purchasing with the COA that they're being provided is actually accurate. So we can do nitrogen purity, and we can also do contaminants in nitrogen. So same thing with compressed air, clean, dry, oil-free. We can do clean, dry, oil-free nitrogen as well.
And I know there's different tests and things. What's the typical turnaround time for compressed air testing, etc.?
So our typical turnaround time is 5 days for laboratory analysis. So we like to say 3 to 5 days. I like to give us a little bit of a safety cushion, Simon, if you know what I mean. So 5-day turnaround time. We do have like rushes available, but we're limited on how many we can rush because, again, we're doing 100 samples a day. So sometimes it's tough to squeeze those in. But typically the return time on a sample is 5 days.
Yeah, and I know I was speaking with you before the webinar. You are growing quite significantly on export, and Steve's mentioned there, are you global? I think Steve's based in the UK. And also, what about turnaround times for exports?
I'm for outside of the country. Is that what you mean?
Yeah.
I usually, it depends. So Canada, Mexico, typically we only see 1 day because of customs. Depending on the type of analysis, it varies. Going overseas, it really does. But typically, it's not too impactful. We cannot do microbial overseas for obvious reasons. But if you're in the States or you're in Canada, we have partners in Canada, and we have ways to do micro. All of our containers and shipping methods for those microorganisms have been validated, and we have all those documents in place for any quality program that wants to work with us. But overseas is very difficult for micro, but we can do particles, water, and oil overseas. As far as the turnaround for shipping, I'm just not sure.
Yeah, sure.
It varies so much.
I can understand that. And Charles is asking, do you have a physical office in Kenya or East Africa?
We do not have a physical office. We have a singular location right now, and that is in Austin, Texas, in the United States.
Okay. Sigal, how is testing done? Does the user take the sample, or do you send a technician?
So we are a laboratory. We have a trusted technicians. We have trusted technician service providers all over the country. We have some in, abroad as well. However, we do not do the test. We do not perform the testing, but we can have a service provider that is trained and certified to our testing methods come and help you. But you also can do it yourself. Again, Simon, we talked about it a couple questions ago. We try to limit folks testing themselves only because once they get those results back, they're going to need to take corrective action. And us as a laboratory, we can't always help with that installation that filtration installation, that dryer maintenance, that installing or recommending preventative measures. So we always like when our customers work with technicians or work with one of our service providers who have a robust knowledge of those systems and have familiarity with yours.
Okay, great. Steve, question. BCAS took into account potential microbiological activity and went for drier air for both direct and indirect food contact.
That makes sense. We see that in breathing air too. Our moisture limits are really, really low in breathing air, and that's to prevent microorganisms. So that makes total sense.
Okay, Maureen. Hi, I'm Maureen, working in a food industry and currently in the implementation of FSSC 22000. Our compressed air is oil-free. My question is, are there any limits defined for microbes in compressed air, as I'm unable to find it? Thank you.
So limits, not yet. So earlier in the presentation, and I know I said a lot of words there for a moment, but limits for micro are not defined yet. That is coming very soon. We at Trace Analytics actually have folks on the ISO 8573 committee, and they tell us that limits for micro is coming soon. You'll have one of those purity class charts very similar to particulate water and oil. All things microorganisms for ISO 8573 can be found in ISO 8573-7. Whatever is in there currently is what you will have. But hopefully very, very soon we'll have limits. My only recommendation for limits is to, again, work with your quality program, work with your micro folks, and try and determine what your alert levels are going to be, and lean on your environmental programs. A lot of you have environmental programs in place right now that are for ambient environments or settle plates and things like that. Let's talk about maybe your alert levels there and if they should be similar or if they should not to what's in your compressed air. Again, it's all about that direct contact risk.
Okay, and Steve's just asking, do you know, is there a date, an ETA for the limits, or is it?
I do not know. I will have to ask. I'll have to ask. We have a coworker.
Yeah, but it's
Yep.
Work in progress. Yeah.
Yes.
Okay.
Yep.
Sonia's asking about a list of countries in Europe with lab accredited to carry out these tests. And I'm sure they probably are, but yeah, I'm not sure that you would be proposing those, Brett.
I mean, we have resources in Europe to a degree. So yeah, Sonia, we can reach out to you and help you as much as we can. Like I said, it's not about testing with us; it's just about testing, right? Like
Yeah.
let's so
Okay. We'll send that question with your email directly to Brett and the team, and then they can follow up with you individually. Question from Mark. What are your thoughts on the use of HEPA filters for environmental air prior to going into the compressor? Was this ever tested? If so, what type would you recommend, or have you seen in the industry?
Yeah, we've seen HEPA filters installed on intake air filtration. Now, our industry for 30 years has been compressed air testing. So as far as ambient, really, again, those service providers that know those systems, they know more about intake air than we do. But I have seen HEPA filters installed, especially on blowers and other types of, we won't say compressed air because they're blowers and vacuum, right? But yes, we see HEPA filters work very efficiently for intake air on compressed air systems, blowers, and vac.
Okay. There was a question previously came up, I think, on a previous webinar about actually when to test, and one was about maintenance. So what's your recommendation about testing before, after maintenance, things like that?
So I personally, I think most of the standards or most of the guidance you're going to find is going to say regular testing as well as after any maintenance. However, I like to try and encourage a lot of our folks to be testing before and after service. And that's got nothing to do with the fact that your tests may come to a laboratory. You can use continuous monitoring or another resource that I showed in earlier slides. However, when you're testing before and after service, that gives you a good glimpse of the redundancy of your system and how it's performing all year round. I mean, obviously, when you take a sample after service, oftentimes it is perfect because your filters have just been changed. Your compressor is running its optimal efficiency. But when you take a sample beforehand as well, or ask your technician to take a sample beforehand as well, it'll really give you a lot of insight to what your system was doing before you upgraded those filters. If you're changing your filters once a year or every 6 months, and your sample that you took before you were testing comes back and it wasn't as clean, dry, and oil free as it should have been, now you know, hey, maybe we should be doing this quarterly instead of every 6 months, or maybe we need to be doing this every 6 months instead of annually, just to make sure that our system's always performing as clean, dry, and oil free as we need it to be.
Okay, great. Any more questions? Well, we've got Brett with us. I can say that you're always open to. Have you got your oh yeah, there you go. Brett.greenlee@airchecklab.com. So I know Brett Trace are very open to helping customers and answering questions, etc. So if you do think of anything afterwards, you can always, I'm sure you'd be open to that, would you, Brett?
Yeah, absolutely. That's what we're here for.
Very good. Because I don't think there are any further questions right now. Okay.
Perfect. Yep.
So what I'll do is I'll load the certificate, because the certificate of attendance for today's webinar. You can download that now. I will be following up with an email with the recording slides and certificate afterwards, and I'll pop Brett's, well, you'll have Brett's email on the PDF slides. So yeah, so thanks very much, Brett. It's been great. We've got one more Food Safety Fridays till the end of 2024. That's gone so fast. So yeah, have you enjoyed it? First one with us.
Yeah, absolutely. Yeah, it was a blast. I really like the Q&A. That's really where I thrive. You know what I mean? Answering questions. So if you have them, please send them my way. You know what I mean? Sometimes when you're presenting and there's no back and forth, it can be a little bit rocky to get the information that's needed across. So Q&A is my favorite part. Yep.
Well, on that note, there is another question.
Yeah.
So, although we've wrapped up, we will take it. Priyanka, how to test microbial quality in-house of compressed air.
So if you have an in-house micro lab, we have seen this before. We do offer equipment that are we offer impaction sampler equipment, which again, impaction samplers are the only type of accredited, or sorry, not accredited, but ISO 8573 accepted method for testing microbes. We have those impaction samplers for rent and for purchase, and we offer training and instructions on how to use them as well. And then you can just take those plates and analyze them in your lab. A lot of times there's some benefit to testing with us, just as a added layer, you know what I mean, from your in-house lab, since we're third-party accredited. But we do see that from time to time.
Okay, thanks very much. Yeah, and Charmaine, you just need to add it yourself, either write it on or edit it with image editing software to add your name. Right, super. All right, have a great weekend, Brett. Thanks for your time today. And well, we're planning the Food Safety Friday schedule for next year, so hopefully you can join us on one of those.
Absolutely, and you know what I mean, for anyone that celebrates, happy holidays as well.
Yeah, cheers. Thanks, everybody. Thanks, Brett. Have a great weekend, and we'll see you next week. Cheers.
Yep.